Assalamualaikum warahmatullahi wabarakatuh, and hi, welcome to my lecture series. Today we are going to talk about the introduction to hydraulic turbines.
In order to begin this, we are going to see what is actually a hydraulic turbine. Hydraulic turbine is a mechanical device that can convert the potential energy in the flowing water or water stored in a reservoir at a suitable height into mechanical energy, or specifically rotational mechanical energy. In the early days, machines of such concept were called water wheels and were used mainly for household tasks such as grinding corn and lifting water. In modern times, hydraulic turbines are used almost exclusively for driving electric generators. The electric power generated by such machines is called hydroelectric power. Hydroelectric turbines convert potential energy into rotational mechanical energy. They do this because the water passes through wicket gates onto a runner, and this causes the runner to rotate. The runner and an electric generator are mounted on the same main shaft. Therefore, the rotational mechanical energy from the runner drives the generator up here, turning the mechanical energy into electrical energy. The amount of energy that can be converted depends on several factors, such as the available heat. This is amount of water above the pump or the height of the water above the pump. The flow rate through the turbine and the efficiency of the turbine itself. Hydroelectric turbines can operate a wide range of pressure and flow rate, but there is no single turbine that can work at all pressure and flow rate. So you have very different and distinctive design depending upon the condition in which the turbine will be operating. The main types of turbine that you are likely to see are Pelton turbine, Francis turbine, and Kaplan turbine. Pelton turbine is named after Lester A. Pelton, who patented the design in 1890, perhaps the most distinctive appearance or shape turbine. The first well-designed Francis turbine was built in 1849 by a hydraulic engineer named James B. Francis, and a propeller turbine with adjustable blades is called a Kaplan turbine, named after the German professor Victor Kaplan, who developed such a machine between 1910 and 1924. Hydraulic turbines are classified into two broad categories: impulse and reaction type turbines. Pelton turbine is an example of impulse type turbines, while Francis turbine and Kaplan turbine are reaction type turbine under two different subcategories, which is radial flow and axial flow. Type turbine is pressure turbine, have a continuous body of water or unbroken body of water from the upper reservoir all the way down to the lower reservoir. The water body is unbroken. The reaction turbine functions because as the water flows through the runner, there is a pressure difference between the upper and lower reservoir, and this pressure difference causes the runner to rotate. And just remember that reaction turbine is pressure type turbine. Impulse turbines are pressureless type turbine, but the process is more dramatic. They work by shooting a jet of water at the runner. What they actually do is they direct the jet tangentially into buckets, and this causes the runner to rotate. So remember, impulse turbine, no pressure, and also the body of water is broken. Taking from the suction side, then shooting it at the runner causes the runner to rotate, and water is just drained away. Hydroelectric turbines are also classified by not just their design and operating conditions, but also by the heat. Low heat, for example, is between 5 to 30 meters. Medium heat will be from 30 meters to approximately 300 meters. And high heat would be anything above approximately 300 meters. Turbines are also classified by their orientation, if they are horizontal or vertical. We have discussed a little bit about the main type of hydro turbines, and we also know that they can be classified into two broad categories such as reaction and impulse turbine. Now we want to look at why we have the different design and when we will use them. This graph shows the application range of different type of hydraulic turbine. On the left hand side, on the y-axis, we've got head of pressure going from 5 up to 2000 meters. And on the lower scale here, on the x-axis, we've got the flow rate in meter cube per second. So we're going to start at the bottom. We've got here horizontally orientated Kaplan runner, which usually installed in a bulb turbine. We can see that it is at the lower end of pressure head scale, going from 5 up to about 20. And we can see on the lower scale, it needs a flow of minimum 2 meter cube per second up to a maximum of about 700 meter cube per second. This type of turbine is suitable if we don't have a high pressure head, but we have a high flow rate, for example, river power station. If we got a high flow rate river, we just need to dam it slightly to create at least 5 meter height drop. Another good example for bulb turbine is tidal power generation. We go a little bit higher up the scale, we've got a vertically orientated Kaplan turbine. This turbine can be operated up to a pressure head of about 70 meters, and for flow rate it can do for a very high flow rate up to 1000 meter cube per second. The vertically orientated Kaplan turbine covers almost all range for bulb turbine, and it covers from the low head to the medium head pressure range. Now we go further up, we can find a new type of runner, which is the franchise runner. Franchise runner have the widest range of applications. We can see clearly here, the blue area covers from 20 meter all the way up to about 800 meters head. And for the flow rate, it covers almost the entire graph from left to right, from 1 meter cube per second up to 1000 meter cube per second. This is very versatile turbine. Franchise turbine is the most common turbine simply because it can operate at a wide range of pressure and flow rate. Now we will move to our final type of turbine, the Pelton turbine. This is used for high head of pressure applications. Generally, we can see Pelton turbine when we have an application of very high pressure head and flow rate and low flow rate. For example, if we have a very high upper water reservoir and a very low water reservoir like this one. So I hope you have a little bit introduction about hydraulic turbines, the three main types, their classification, and the range of applications. If you got any comments or suggestions about the video, please do get in touch. Thank you very much for your time. See you again. Wassalamu alaikum warahmatullahi wabarakatuh.